So a quadratic is an expression or an equation that has a power, which is why you were taught exponents before, because now the word power makes sense to you. A power of at most two on top of the variable. I'll explain what this means. So at most, sorry, let me use a different color, 2. Okay? So that means if you ever see an equation with a power of what? No, with a power of 3 or any equation that has a power more than 2 is not a what? It's not a what? It has many other names, but we are not responsible for them in this course. So the maximum power we should look for is what? Is the power of 2. Okay? So, in other words, if there is a power higher than 2 or larger than 2, larger than 2, it is not a quadratic. What is it? I don't care. We do not care what it is. We just care that we are not responsible for it. The only thing we're responsible for is a power of 2, and that's it. Okay? It could be a lot of other things. For example, and I'm not going to ask you to remember this for the rest of the course. I'm just going to have it on your notes today. If it has a power of what? No. Actually, if it has a power of 1, it's a straight line, which is a lot of grade 9 and grade 10. If it has a power of 3, there's a power of 3. What's another name for a box? Starts with a C. Yeah. See? So that's what, because a box is three-dimensional, when it has a power of 3, they call it a cubic. Not a quadratic, a cubic. So it is called a cubic. C-U-B-I-C. It is called a cubic. That's a C-U-B-I-C. However, in this course, we do not deal with those. We only keep it to what? To quadratics. Okay? Okay, what if your, everyone, what if your power is not bigger than 2? What if it's what? Less than 2. But less than 2, but is a decimal or a negative or a fraction. Also what? Not a quadratic. So the good news is quadratics is a very strict thing. If the power is anything but 2, sorry, we do not deal with it. So if you ever spot a power other than 2, just say, oh, this is not even a part of this course. That's it. That's all. How about grade 12? Yeah, grade 12, they go a little bit into powers of 3. But in grade 11, it's only power of 2. Okay? Here's another way to recognize what a quadratic. Quadratics always look like that. Everyone, just eyes on the screen. Quadratics always look like these shapes. Always. Not a single quadratic ever will have a shape different than this. All of them will look like upper U or what? Like either base. Yeah, a quadratic basically. Everyone, the easiest way to think of a quadratic is it's a ruler that you can bend. That's it. It could be this way. You could bend it to make it thinner. You could bend it to make it what? Wider. You could flip it, and you could make it thin, or you can make it what? But everyone, listen up. You can never turn it this way. Never. It's either open up or open what? It's never open to the left or to the what? Yes, there you go. Every single time. All right? And by the way, it has to look perfect. What I mean by that is this. It cannot look like this. Do you see what I mean? It cannot look like one half is thin and one half is what? Why? It has to be a perfect symmetry. How many people have heard of the word symmetry before? What does symmetry mean? If again, no need for a tough explanation. Peter? Sorry, you go ahead. What exact? What is exact? Is my face symmetric? Oh my God, come on, man. Why did you just slap me across the face as well? Is there a line that separates my face into two identical halves? That makes my face what? Symmetric. Yes. Yes. So if you do not sketch it symmetrically, you made a mistake. All right? Okay. That was a fun one. No, your face is not symmetric. Okay. So one very easy way to see if something is quadratic, its graph is Yeah. Adil. Who can pronounce this word? I've heard it in two ways. I guess that word. Everyone. Who can pronounce this word? Raise your hand if you'd like to try. Yeah. Okay. So the English way of pronouncing it is that you have to put the emphasis on the R. Parabola. Okay. However, it could have a what? It's basically a Latin word. A Latin word. And I've heard some people say parabola. But most of the time I heard what? Parabola. Let's say it together. Parabola. Parabola. A parabola is basically what? Any curve that looks like this. Done. From now, from now until the day you finish math, if you ever see a curve like that, you call it a what? A parabola. Okay? Every single time. Okay? A parabola is any shape that looks like those ones. As long as it's curved and it looks like an up U or a downward U, 100%. Every quadratic we're going to sketch from now until the end of the next, I think this unit should take us about, same thing, 4 weeks, is going to look something like that. Also, are they all in the same location or all over the place? Yeah, you can move a quadratic or a parabola anywhere you want. You can make it in this quadrant or in this region, down, up. Question for you, everyone. How many times is this one cutting the x-axis? 2. How many times is this one cutting? How many times is this one cutting? How many times is this one cutting? So they could be cutting as many times. They could be located anywhere. We're going to talk about more about that next week. Okay? All right. So now let's actually look at each one here. And I want you to help me decide. Sorry. If it's a quadratic or not, and you have to explain why. All right, everyone. Pencils down. I just want to discuss. Do you think this one is a quadratic? By the way, you know what the easy test is? Sketch it on Desmos. And if it produces a parabola, open up, open down, left, right, sorry, open up, open down, located here, it is. Who would like to say this is a quadratic? Okay. Who would like to tell me an explanation? Abu Bakr, give me one explanation why you believe this is a legit quadratic. There is a power of what? There is a power of 2. Okay. Do we really care that the power of 2 is on top of a bracket? No. Okay. Let's do the proof. Everyone, just give me a second to sketch it. All right. Desmo is my best friend here. It does. And we have what do you call it? We have yes. Yeah, go ahead. We have. Oh, you can just put it in the office. Oh, actually, put it here, and I'll collect it. Sorry. Yes, it matters. It's not just any 2. It's a positive 2. And I'll show you that if you make it a negative 2, the whole thing will not become what? A very nice curve like the one we're used to. Okay, everyone. So look. Hide. Okay. Tell me what the. Okay, where's the? There we go. Okay. What's the equation? Y equals. Come on, help out, please. Y equals what? Oh, negative. Okay. Bracket. Hold on. X plus 5 close bracket. Go to a power of what? 2. You can go right here and click 2. Keep going. Plus. Oh, minus. Is this a quadratic? Done. That's it. So everyone, let's answer the first question then. So first, let's sketch it. So here is my. Oops, sorry, my bad. Can someone tell me which part of the which part of the grid is it? Was it here? Was it here? Was it here? Was it here? It was here. And was it open up or open down? Great. That's all. By the way, it should have a sharper turn, but whatever. As long as it looks a nice U, we're good. Okay. So what was the decision? Yes or no? Quadratic or not quadratic? Yes. So the decision is quadratic. Okay. Quadratic. I think I might have to change the layout. Just a second. So, there we go. Oh, sorry. Yes, now we're good. Okay. What was the explanation? There's a power of what? Done. There you go. So everyone, explanation is there's a power of 2 there. Sorry, there is a power of 2 above bracket. Above bracket. All right. By the way, technically, what an explanation could be, I sketched it and it looks like a parabola. But obviously, you're not always going to be able to sketch. Sorry, you can sketch. I'm pretty sure all of you can sketch now. I'm saying you're not always going to have quick methods of sketching. Yes, sure. Okay, next one. Who would like to feel this one? Come on. Ragad, why don't you go for it? Ragad, what do you think? Everyone, Ragad's going to tell us what she thinks about the second equation or the second expression or the second function. Ragad, do you think it's a quadratic or not? Why not? And you are right. Why not? How? The power is what? -2. We said explicitly it needs to be only what? +2. Perfect. So okay, what's the proof? Let's what? Let's make a what? It will never look like anything like this. Okay, everyone? So, Ragad, you tell me what the equation is. Go. Let me just delete. 1 second. X. Oh, yeah. Okay, everyone. The name before the equal sign is okay. It could be Y or F or H, just the name of the function. So I can call it Y. Yes. Oh, 3. Okay. 3x to the power of -2. So I need to add a negative here. There we go. Keep going. -5x plus 3. Is this what we want? Look at it. Can someone tell me how different this one is from all the other ones we've seen so far? Is this one like go ahead, Kristen, tell me. Briefly, tell me why this one is not a parabola shape. Exactly. By the way, could we say, well, can't we call this a parabola? Is this really that symmetric or is it more like tilted this side? Look at it. It's tilted. Also, is this function made of one piece or two pieces? Look at this. Is it one piece or two pieces? What did we say about quadratics? How many pieces is it? It's a legit single ruler that you either bend this way or this way. Sorry, that is not. So it doesn't answer your question now, right? The power only can be what? +2 only. All right, good. So, okay, how does it look like? This is going to be a weird one to sketch. I need like a little curve there, and then something like this. Okay, everyone, let's sketch it real quick together. Come on. Yes, so everyone like this and like this. Okay, everyone, focus with me here. Here's how it looks like. There's a branch that looks like this one. Look, there's this branch. I'm going to zoom in to see it. See, there is this branch, and then there's a branch that goes up and goes down, but it keeps curving as you go down. All right, whatever it is. I mean, you are not going to get. That's it. Done. Come on, come on. All right. So, Ragad, what was the decision again? Yes or no? It was a no. So, not quadratic. Not quadratic. By the way, I'm okay with you if you write quad. Quad in this course will only mean quadratic. Explanation. A power. A power is a power of -2 is uh, is included. You cannot include any powers but 2 or 1, and that's it. A power of -2 is included. That's the explanation why it's not. Okay, Sebastian, would you like to feel the third one? Everyone? So here's the third one. Oops, my bad. Go ahead, Sebastian. Okay, what's your guess? What's your gut feeling? It is. Oh, and you are right. Why do you think that is? It's a positive power of what? By the way, everyone, do I care that there's a fraction here? I only care if there's a fraction where? In the power. The power cannot be anything but a 2. Anything else could be anything else. Again, the proof is in the sketch. All right? Sebastian, what do we have? Go ahead. Y equals, 1 second. Y equals, no, negative 2 over, okay, fine, divided by 3. Keep going. A squared, or I could make it what? X squared. Everyone, I'm going to just call it x squared. X squared. Keep going. Is it a plus or a minus? Oh, power of 2. Yes, yes. After plus 2, so 2x. Yep. hmm Plus 9 over 14. Oh, 14. Sorry. Is this a parabola? Oh, oh, my bad. Thank you. Is this a parabola? Done. That's it. Okay. So, okay, let's see how it goes. It exists here. It cuts a little bit to the left and then goes up and down. All right. I just want to memorize the behavior. That's all. Right. So, quick graph. I'll do it in red again. So it's here and here. So it goes up and down. Done. That's it. Go ahead. Up and down. Okay. So what's the explanation? The explanation is uh, there is there is a power of 2 above the variable. I want you to say above the variable. And the decision, as Bastian said again, was indeed a quadratic. My bad. Stepping in front of you. Okay. Raise your hand if you'd like to do the fourth one. Come on. I want this to be a discovery thing. And if you get it wrong, so what? We learn. I got them wrong too. Rachel. Go ahead. Who would like to do this one? Christian, yes. Everyone, Christian is going to field this one. You go. Is it a quadratic or not? That one. Thank you. There is a power of 2, but there's also a power of what? And we said the maximum power that could exist is only up to what? Thank you. Done. Perfect. Christian got it. So everyone, not quadratic. Not quadratic. Why? There's a power of 3. You don't even need to tell me on what variable. It's the same variable. It's a W, but it's been repeated twice, and one of them got a power of 3. Sorry, that's bad. There is a power of 3. Not quadratic. There is a power of 3. Okay, what about the sketch? Okay, y equals y equals negative. I'm going to call it x instead of w. Who cares? The name of the variable is up to you. X to the power of 3. Hey, what's up? Yeah, go ahead. Can someone tell me what's the rest of the equation? Minus x cubed. Keep going. Come on. Minus 2. Sorry. So what's after that? 2. The Oh, again, as long as you change all of them to the same thing, it doesn't matter if it's an x or the. I'm just making it easier to look like as far as x is concerned. That's all. But you're absolutely right. It should be always whatever the question says. X to the power of what? 2. Keep going. Plus 9. Is that a parabola? I'm sorry. No. You might say, well, what about this part? I don't care about the part. I need the whole thing to look like the ones we have. By the way, cubics always look like this. They go down, they curve up, and they go down again. Or they go up, they curve down, and they go up. They have always this peak always in it. Yes, Christian? That's what? a C straw, or silly straw, or this is so this is a cubic. Everyone, this is what we call a cubic because it's a power of what? Power of 3. Now, how does it look like? So it goes down and then goes up, right on the axis, and then down. Okay, I think I memorized it. All right, let's go green. So you go, and then you go up, and then you go down. Done. That is not a parabola. By the way, I'm going to put a check mark next to the ones that are parabola, just so we have them. Okay, who would like to do the next one? Yes. Anyone for that one? Yes, Colin. Sorry. Yes or no? Quadratic or not? Not. Colin got it right. It's not a quadratic. Tell me why. The, okay, hold on. There's what? Say exactly what you said. Colin is saying there is no power at all. Colin, question for you. Let's look at this. I know it's not the same, but when you don't see a power on top of a variable, technically, what is the power? Is it a 0 or a 1? It's a, so technically, is there a power? Yes, it is. But what is it? 1. So did it make it up to 2? So it's not a quadratic. Can you tell me what is the only geometric shape that has a power of 1? If it's not a curve, it's a what? No, no, a circle is a curve. A straight line. Thank you. Everyone, raise your hand if you remember y equals mx plus b. Y equals mx plus b. When did we learn that? We learned in grade 8, in grade 9, in grade 10. Y equals mx plus b is the equation of a what? Of a what? Of a straight line. That is an equation of a straight line. So everyone, I want you to put power of 1 on top of the h. See, Kylan said it right. He said there is no power at all. But he actually meant to say there is no visible power at all. There is a power, and it's a 1. Everyone, go ahead and put a 1 here. Oh, my bad. I'll just, sorry, it's going to keep dragging it down. So basically, just make it 3h to the power of 1 like this. Yeah, there you go, like on top of it. Okay. It's a what? No, no, 1. 1. Everyone, it's a 1. It's a 1 on top of the h. So the decision is not quadratic. Not quadratic. And the explanation was what? The only power is 1. Quick graph. Sure. What is the quick graph? Okay. What is the equation, everyone? What's the equation? Yeah, see, that's the thing. I don't have a z here. That's why I always call them y and x. So y equals, yep, what? Negative 3. Nice. Negative 3x instead of h. Keep going. Plus? Plus 4. Come on. That is a what? That's a perfect tilted straight line. Straight line. So you just need to cut, everyone. You need to cut a little bit above the origin. All right. So go ahead, and I'm just gonna sketch that. And that. And there we let me just lift it up a little bit. Yeah, like this. Nice. Everyone, go ahead. That's it. That's a straight line. Okay? All right. Who would like to do this one? Come on. Come on. Who would like to do that one? Yes. Sorry? Anyone other than Kristen? Kristen, go ahead. Everyone listen up. Go. Is it everyone? Is there a power of 2? Shh. But there's also what? Any power different than 2, aside from 1, in the expression will screw up the whole thing. And it's not just a 3, it's a what? It's a negative. It's both bigger and negative. Where's my what? Oh, there. So a decision, not quadratic. Go ahead. Not quadratic. Not quadratic. Not quadratic. What was the reason? There's a power of -3. You don't even need to tell me which variable it's on. You just tell me there's a -3 and it's causing trouble. There's a power. There's a power of -3. What do I do now? Quick sketch. All right. Okay. There's a power of -3. All right. What do we have? Y equals. Okay. What's the first thing? Anyone? 3 or 3x to the power of what? So I'm going to have to make it -3. Keep going. Plus. Oh, oh, minus. Okay. Minus 5. So 5x to the power of 2, which is a good one. Keep going. Huh? Plus 3. This is like which one? Come on. Did we do a similar diagram like this before? Yeah. But instead of what? Instead of this one being here, it was where? So basically, it's got like the whole thing flipped. But again, is this a quadratic? No, it's not, because it's made of 2 parts. Sorry, a quadratic is only one single piece, either this way or this way. So how does this look like? I'm going to have the curve this way, and then go up and go down. All right. Goes here and here. All right. Got it. Go ahead. Come on. Just to look something like that. Okay. Up. Oh, you mean? Oh, you mean the row above? Good. Okay. Who would look to? Sorry. Who would like to do the next one? Come on. Christian already got 2. Colin, would you like to do the next one? Everyone. Colin's got. Oh, Peter. Okay. Sorry. Peter, go ahead. Do number 7. Colin already got 1. Peter's got to tell us what he thinks about number 7. Okay. So you're saying no. Give me a reason why not. By the way, you are right. Uh-huh. There is a power of 2, but that's not always all we look at. We still check the whole thing. Caleb? Uh-huh. Yes. One of the powers is what? Sorry. What did everyone look? What did we say here? If any power is what? A decimal or a negative or, that destroys the whole thing. Even though there's a power of what? Sorry, you have got to look at all of them. It's a package rule. Either all of them work or none. Yes. So it's not quadratic. Well, that's the thing. It can't be. It's either fully yes or fully no. So this one is a full no. Not. Yeah. I randomly picked. Okay. So what was the reason? There's a power of half. Done. Everyone, there's a power of half. There is. There is a power. A power of zero point 0.5. Done. That's it. Okay. How about the graph? How about the graph? Who can tell me what the equation is? Y equals. Hmm, come on. Negative 2 divided by 3 x squared, which is a good part. So x squared plus, hold on, 2x to the power of zero point 0.5. So 0.5. You see, it already screwed it up. What did it do to it? Everyone look. It was a full one, and then what happened? Yeah, it cut a part of it. Sorry, it's either a full ruler or not a part of it. What was the next? Plus 9 by 14. Yeah, that's not going to change much. Yeah, barely any change. All right, so how is this going to look like? You have got to start, everyone look, you have got to start from here, like from the axis, jump up, and then go down. So start from here, jump up, and then go down. Okay, I had to give you a tricky one. What do you think? By the way, everyone, we are going to study things that look like this a lot, probably by the end of next week. But who would like to take a guess? Maybe it's an educated guess. What do you think? Colin, yes or no? Colin's saying no. Tell us why you're saying no. Everyone listen up. I, uh, so, okay, everyone, look. Colin is basing it on his reasoning of the first one. The one he did before had a power of 1 here and also a power of 1 here. I agree. There are ones there. In fact, I urge every one of you to put a 1 on top of that x and a 1 on top of that x. Go for it. But you know what? Let's sketch it and see what we get. All right? Let's sketch it and see what we get. So what is it? Y equals, 1 second, bracket, yes, wait, 3x, come on, plus 2, close the bracket, open another bracket, multiplication, yes, 2, 2x minus 4. Are we ready? Okay. Whoa, what is it? Is this a parabola? Is it like one of the shapes that appears on the first on the top of the page? Yes, it is. So apparently, it is what? Is that a quadratic? Everyone, is this a quadratic? Yes, because the shape is the final test. The shape is correct. This is a quadratic. My question is, however, where is the power of 2? Because every one of them had a power of 2. This one doesn't. Or does it? Abu Bakr, you had your hand up first. Say, oh, nice. Go. If you what? If you add a 1 to a 1, what do you get? Everyone, how many people have heard of, listen up, expand, expanding? When you multiply like this, how many people remember things that look like this? Sorry, like this. We did that in grade 10, and we will do that a lot in this grade as well. When you expand, what do you create? A power of what? You take 2 powers of 1, and you create a power of 2. So it's hidden, but it's there. Good, nice. So how about we explain it this way? Again, this one should be above, please. Okay, so the decision is quadratic. Quadratic. Explanation, both powers of 1, both, I want you to write both powers of 1 will multiply to give you 2. Will multiply to make 2. Great. Now I need to look at the graph and quickly do it. Just give me a second to look at the graph. So I have a thin parabola that goes down, cuts, and then goes up. All right. So it goes One second. Let me just finish this. So it cuts here. So it goes down. You have to make sure that your lowest point is on the right side, not the left side. So it has to look like this. Look, nice. That's a decent curve. Remember, you are never marked wrong for the curvature of your curve, as long as it looks like a curve, not like a legit straight line. Go ahead. Okay, and that's it. That's it for what knowing just by looking if it's a quadratic or not. All right, let's go everyone to the next page and sketch a quadratic, which is really gonna be similar to the question you had on the test when you had to sketch a what? Sketch an exponential by plugging in the values. All right, everyone, let's go right here. Okay. The first thing is we have to calculate the value of what? Sorry, like we have to plug in the value of what? Where? Here and here, wherever there's an x. Okay, let's start. So just follow me for the first one. What do I put first? A negative. And then I put a what? A bracket. What goes in the bracket? But it's an x now. That's what? Exactly. It used to be an x. Now I know a value for the x. -7. Then you close the bracket and you put a what? A power of 2. You got it. Bed mass. Bed mass. Just very slow bed mass. -5. Open a bracket. What goes in the bracket again? -7. -1. All right. Let's clean this up. Everyone, just focus with me here. Forget this minus for a little bit. This one. What's -7 squared? What's -7 times -7? -7 times -7. What's a minus times a minus? +49. But there's a what? So it's -49. Not because of this negative, because of what? Yeah, there's a negative here waiting outside. So -49. Go ahead. Okay. What's a negative times a negative? Positive, yes. So positive what? What's 5 times 7? Anyone? 5 times 7. You have calculators and cell phones. 35. And then minus what? All right. What's the final answer? Okay, well, let's think about this. You lost $49 and then you gained $35, but then you lost again $1. So are you more of a loss or a gain? You're definitely more of a loss. How much? Well, I like to do it this way. I like to do the negatives together, so I know that losing 49 and losing 1 is losing 50. Then someone gives me back 35 bucks. Sorry, that's not enough. I'm still what? In the hole by how much? 15. -15. Everyone? -15. Okay. Do we have a -15 on the grid? Everyone? Yes, we do. Okay. Everyone, can someone tell me where my point is? Who would like to say it? You can use a laser point. Hmm, there you go. Let me zoom in for you to really see well. Go ahead, my friend. Yes. So, but we're exactly on the grid. I'm not just asking for the depth, like the point exactly itself. Where's -7? Hmm. Oh, Bakr, where's -7? Right? I think right here, right? And then, am I gonna go up or down? How many steps? 15 down. Where's 15 here? Can you tell me? So exactly where as well? Yeah, right here, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Nice. Thank you, my friend. All right, so everyone, 15 is here and -7 is here. Go ahead, everyone. Here's your. Oh, oh, there we go. Everyone, here is my point. -7 right here. Oh, I need to change the layout. My bad. There we go. Yes. Okay, everyone, here is my point. My point is, as Abu Bakr perfectly penned it, right here. Come on. -7, -15. Okay, I think the battery is a bit off. Yeah, it's been good for the last couple of weeks. Okay, next. Can someone tell me how much am I going to change here? Is it going to be almost the same procedure? It never changes. That's the good thing about plugging in. It's like you're on Microsoft Excel. By the way, do you see how easy this would be on Google Sheet? Yes. You just have to what? You just have to write the equation. You know what? Actually, let me show everyone. Check this out. Excel. Everyone, look. Come on, let's do this real quick. Okay. What's my first value on the x-axis? Come on. -7. Now, what's happening to every value below? Is it getting lower or higher? Ooh, hold on a second. Everyone, think of temperatures. What happens if it's -7, -6, -5? Is it going colder or warmer? Which means it's going higher. Remember, negative numbers are always what? Opposite thinking. So I should say what? Let me zoom in. Oh, okay, fine. 200. I should put. Ooh, I should put what here? I need to make a what first? No, equal sign. Equal sign. Remember, because I'm putting an equation. Equal. Now, what do I click on? I click on this number because I want to add what to it? I want to add 1 to it. So I'm going to click plus 1 -6. Now what do? You drag. You never bother. You drag. Let's drag, everyone. So I'm going to drag like this and drag. What's my last value, by the way? Is it 2? All right. Click. Okay. Now, everyone, check this out. I'm going to show you how to put the equation. Come on, focus with me here. Because at least now you know a way to check your answer. Okay. And I'm going to make it longer, like a bigger cell. Okay. Sorry. What's the first thing you enter? No. Equal. Okay. Everyone, pencils down. Pencils down. Pencils down. Eyes on the screen. Phones away, please. Your phone's not going to teach you this. What's the first thing I put in? Negative. Then what? I need to click the 7, the -7, and put it to a power of what? 2. So I'm going to put it in a bracket. I don't need to, but let's do that. And then I'm going to click on the -7. Nice. E5. Close the bracket. How do you do a power in the Microsoft Excel? We know that a multiplication is the star. What's the power? Yes, the hat symbol. The hat symbol. So where is it? I think it's Shift 8. No, Shift 6. There we go. To a power of what? 2. Keep going. What's the rest of the equation? -5 times. You cannot just put a bracket. You have to put times. Where's times? Times. Times which cell? Oh, yeah, I can just put E5. E5. Nice. Then what? -1, my last constant number. Ready? Oh, that doesn't make sense. Did I make a mistake? I know. Hold on. E5 squared. Whoa, 83. Oh, really? Okay. Hold on. Don't think that's a problem. What the? Okay, that does anyone see a mistake? Because I equals minus E5 squared minus 5 times E5. Whoa, now I'm perplexed. This never happened. Sorry, someone said, but there has to be a. Okay. Yeah, see? Nope, it's telling me it doesn't make sense. Sorry, the what? Like, okay, hold on. Let me just put -7. What the? Are we doing something? Minus 7 squared is 49 with a minus. That's minus 49. Minus 5 times minus 7 is plus 35. Actually, honestly, I have no idea what's going on. I've never made a mistake with Microsoft Excel. I mean, you've seen me use it for so long now. Huh? Maybe? Okay, hold on. I don't want to waste time on this. I mean, I know our calculation on the paper is right. What if I do this? Is that 41? You know what? I don't want to waste your time with this. Let's just do the numbers, and then I'll definitely figure it out at some point. Okay, minus 6 squared, minus 5, minus 6, minus 1. Okay, what's minus 6 squared? Or just, yeah, 36, but with a what? With a negative. Good. Minus times a minus, 30. Minus 1 equals. So think money. You lost. Let me squeeze this. Yep, you you lost $36, and then you lost another dollar. That's $37 lost. Someone gave you back 30. Yeah, you still lost $7. Okay, so can someone tell me where is minus 6 minus 7? Minus 6 minus, yep, nice. 1, 2, 3, 4, 5, 6, 7 right here. I got a book, no problem. So minus 6 minus 7 would be right here, right there. Okay, keep going. Minus 5 squared, minus 5 minus 5 minus 1 equals. What's minus 5 squared? Come on. 25 with a negative because it's a negative before. Plus 25. What's minus 25 going to do to plus 25? They zero each other, which really means you are just minus 1. Great. So where is it? It's right here. Minus 5, minus 1. Right here. Do you see how it's starting to curve down? As it should, because it's a quadratic. We're not doing lines anymore. Okay, next. Oh, sorry. Minus 4 squared minus 5 minus 4 minus 1 equals. That would be minus 16 plus 20 minus 1. Now we're getting into the positives because minus 16 and minus 1 is minus 17, but plus 3 is just a 3. So where is that? That is a 3, which is 0, 1, 2, 3. So right here. You see? Everyone, is it curving up or curving down? Which means, is it about to reach a maximum? Yes, look at my hand. I'm about to max out. Perfect. All right, next. I'm not gonna do the whole thing with you. I just want to do it with you until we hit a maximum and go one more point, and that's it. Minus 3 squared. You're smart enough to do the rest as just an application. So I'm just gonna leave it as homework. This is minus what's minus 3? 9. Plus what? Plus 15 minus 1. What is that? Losing $9 and losing $1, that's losing 10, but then someone gives you 15. Hey, you're up by 5. Nice. So where are you? Well, you're up by 5, so you are right here. We're almost there. We're almost there at the max. I know it's a boring process, but just hold on. Almost there. Minus 2 squared, minus 5 minus 2, minus 1 equals minus 4 plus 10 minus 1. Hey, how much is that? Can someone tell me? Come on. What's that? Losing $4? Whoa! This one is a 5? No, no. You're right. It is a 5. Be confident, man. You got it. Everyone, If this is a 5 and this is a 5, what does that mean? Have we reached the maximum? Yes, we did, because we passed it once and then again. Everyone, do you know what this means? This means this. You now know the final values of everything else. What's this one? And this one is what? What's this one? So where's the other three? Right, it's symmetric. No, because it has to reach the exact same thing on the other side. So 2 5s, 2 3s, 2 minus 1. Right there. We know the answers before we even do the calculation. So this is what? And this is what? Come on. Yeah. Exactly the same value because you have to go to the same location. What's under it? Come on. Yeah, whatever we have. -7. Then 15. And you know what? I'm just going to do one of them to prove to you. Up here, you choose. Which one of those that we predicted do you want me to do? The -1, you mean? Okay. Smart. You're using the easiest one to do. With a what? With a 0. That's fine. That's okay. Okay, everyone? I'm going to do this one. So I'm going to do -2 with what in the bracket? 0 squared. -5, 0, -1 equals. Everyone, what's 0 times anything? No, 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 no. Not the power. What's 0 times anything? 0. Minus also what? Minus what? You got mine. Okay, I want someone to choose one of the other ones for me to do. Come on. The 15? All right. Everyone, I have chose 15. So -2. 2 squared. -5. 2. -1. Okay. What's 2 squared? Come on. Did I make a mistake? I think I made a mistake. Whoa. Why do I have a 2 here? My bad. Everyone, it's just a what? My bad, everyone. There's no 2 here. I don't know why I put a 2. And I'm not sure why nobody said anything. Sorry. This is just minus. Look, it has to be the same structure, which means there's no 2 here. Okay, good. What's 2 squared? Come on. 2 squared. 4 with a minus, because there's just a minus before. Okay. What's -5 times 2? -5 times 2. -5 times 2. 5 times 2 is 10. So this is a -10. Let me just move it. Okay. And then what at the end? A minus what? Minus what? All of them at the end have minus what? -1. Okay. Losing $4, losing $10, losing $1. How much did you lose? How much? 15. You see? Once you get two identical, just go back. Okay? So that means, okay, hold on. We're almost done. Just hold on with me 1 second. I just want to put the rest of the point. Okay. Where was this one again? 5. Where's this one? You see how they're perfectly symmetric? This one, and this one. Does this look like a parabola? If you connect them, they sure do. Go ahead. Everyone, listen up. No, everyone. Before you connect, I'm done for the day. But before I do that, everyone, pencils down. Just focus with me. I'm gonna say something for 10 seconds. Can I do this? Does this look right? Watch what I'm doing. Hold on, hold on. Why not? Because that's a straight line, and no curve has a straight line in the middle of it. What should I do in the middle there? Have a little what? Have a little curve, because apparently, where does it peak? Here, or in the middle? Where does it peak exactly? It has to peak somewhere here. We don't see it because apparently it's not on the timetable. That's fine. Sorry, not on the table. So go ahead, and you have got to make sure that you peak a little bit in the middle. There we go. And then the best of your ability to go. There we go. Don't forget your errors, though. Done? That's it. Welcome to Sketching Quadratics. Everyone, your homework is to do the following. Listen up. Your homework is to finish this one, and to do this one. Same idea.